Hello everyone. Let's look at interaction today. So this would be immediately after filtering. The order of these things, I'm sorry, I may have moved things around, so hopefully I'm not going to be referring to lectures that I haven't already covered yet, but I'm pretty sure interaction is the next in the order, and I'm not referring to anything that hasn't already come. But what do we mean by this? Last time around, when we were looking at what were we looking at last time? We were looking at filtering and aggregation last time around. And one of the things I said is how to control the amount of data that you're dealing with, the amount of inundation of data that you have. And the thing that I was mentioning that Tufte sort of ignores is that time is an integral component of many of these visualizations. One of the parts of that time, how time interacts with things, is through interaction. That by having the user do things, it allows that person to stay in control, to manipulate the data themselves, so they feel like they're actually manipulating and controlling things. They don't get lost in the data or as lost in the data. And it also means that there's a time component, because when you interact, things will change over time. And that's what we're going to be looking at today. So we're going to look at some of the previous lectures, and then this hopefully should be a fairly short lecture. And then we're going to be looking at views and faceting. And faceting is the different perspectives, like a diamond has facets. That's what the sides of a diamond are, or any gem that's cut. They change how there are different ways of viewing or looking into something, and it changes how you interpret things. That's directly related to interactivity, because when you have faceting, you want to change which facet you're looking at, what view you're looking at, and that interaction between the multiple types of representations of data actually changes how you come to terms with the data structure that you're looking at. So let's look at what we're looking at. Oh, that was a texture. We're looking at a little bit of where stuff before. This is a couple lectures ago. And we looked at how we can discern different types of textures, for example, and that some of them are harder to read than others. Okay. And we said, well, if you want a pop-out effect, sometimes you need to control everything else, but the one thing you want to have pop up. So if you want a particular color to pop out, you don't use color everywhere. You only use color for when you really want to grab someone's attention. And we looked at Gestalt principles, and we looked at like connection, contour, and encapsulation, common textures, alignment, common movement, that sort of thing. But it turns out that all of this also relates to how we're interacting with our data. Because if a whole bunch of visual effects all at the same time make it impossible to have this pop-out effect, then I need to have the user control when they see different pop-out effects, when they work through manipulating their visualization, and when they want to look at this type of data, then the pop-out effect is for this. When they change what view they have, then the pop-out effect is for something else. And then we looked at some concepts like nested concepts, how we show nested information via encapsulation, overlapping. Literally, it's a visual metaphor. When you have overlapping images, it means the concepts that they're representing are overlapping. Connectivity means that they are connected across groups, and you literally connect things. These are just visual metaphors that map directly to how the data actually works. And we even looked at low-level feature analysis, then to working memory and perception. And again, interactivity has something to do with this. Because if I'm perceiving something, I have to make a decision for how I'm looking at it. My working memory is only temporary, so what I'm seeing right now has to be in working memory. If I need to change what I'm looking at, I have to go into long-term memory to actually recall what I'm doing. So interactivity means I have a better view of what I'm looking at right now, but it does mean I have to rely on long-term memory to think about what I did, 20 minutes previously. Okay, so we were talking about memorable content, titles and text are important, human recognizable objects help you recognize the visualization, and redundancy is important. And so we looked at all this. But here's I love the weirdest charts. 538 is one of my favorite places. It's my obsession right now because of the whole U.S. election. Do they have all the weirdest charts? Yeah, there you go. So here's some of the weirdest charts from the 538. They do actually, this is all going to be fame stuff because quite frankly, they do some really good stuff. Dan Fryer, the speed in which it takes Dan Fryer to do New York Times crossword puzzles. I can't do one, period. This guy is doing them in under 6 minutes on most days. And notice we have this pointillization task where you're actually using the stacks of dots. Our mark is our dots, but they actually end up forming bars and areas as a result. And we're actually using encoding with color to indicate the different days of the week. I think it's a really well designed visualization, and it gets to the point. But you're not actually counting those number of points. You are letting the space that they take up form a visual image to give you this, what effectively almost is a bar graph. And notice that if we talked about color blindness and things we had to worry about when it comes to red green color blindness. I think we were talking about that, but if we didn't, I'm going to just mention it anyways. There are a number of websites that you can go to make sure that your visualization does support red green color blindness. We cannot support people that are extremely visually impaired, but red green color blindness is something that we constantly have to work at. It's like 5% of the male population. So it's a rather large chunk of people looking at these things. We want to make sure we support that. Here's Kobe Bryant, who died this year, I think. This has just been a crappy year in 2020. This is how he was shooting from 2005 to 2006 in his regular season. He's a basketball player, in case you don't know who he is. Notice where he's best at shooting, and where he's above average for the entire league. Like, he's just devastating in this range. But again, you're getting the color is popping. It's telling you exactly what you need to get from this story in a very holistic way. But then you can also sort of drill in and look at it. But those are static. Wouldn't you want to see how that changes over time throughout the season? Or wouldn't you want to see how it looks for when he misses versus when he doesn't miss? As a static image, there's only so much I can do. I can't drill into it at all. So if I have additional questions, there's not much I can do. I would have to make a brand new visualization and look at it. What if we were able to play with the data? And that's where interactivity comes in. So, with an animated transition, just to show off, I forgot I put that animated transition in there. Because animated transitions are there for a reason. You don't like them in PowerPoint, or I hate them in PowerPoint, but they're provided there for a very good reason, because they allow you to track things. One of the uses of animation is it allows you, when you transition from one visual to another, you can track how they change over time. But even if you don't do that, the interactivity itself gives you something that Tufte never sort of discounts. But Ben Schneiderman is very famous for writing this particular paper. It's a thought piece. I think it's, is it The Eyes Have It? I think it's The Eyes Have It. But it's called the Schneiderman Mantra. Literally, he has it. I'll skip ahead a couple of slides. Oh, damn, is the Schneiderman Mantra not just listed down? Oh, come on. There. Literally, in an academic research paper, he repeats himself that many times. That's an actual snippet from the research paper from 1996. Like, it's insane that he actually did that, but it's like, yeah, it's very, very clear how much he thinks this is important. So we'll be looking at that, and some basic interaction functions for visualizations. How we make sure people don't get lost in the visualizations that you're making, how you make sure everything sort of works. So why do we do interaction? Well, we looked at complexity reduction for filtering and aggregation last time. You can also do complexity reduction. Essentially, your filtering and aggregation can come into play through interactivity. So you choose to filter something out, those data items go away. But I don't do it automatically. The user chooses to filter. The user chooses to aggregate data. If it's purely static, there's a particular story you're telling. Versus interactivity, you also get user buy-in. The user gets to play around with the data. The user is discovering the story. There's this sort of guided discovery that you get with interactivity that you cannot get with or as easily with a static image. You can explore data, you can get new insights, you can reason for things for oneself. You're more likely to trust the data. You can dive deeper. It's personal to the viewer, and then the viewer now thinks, well, I did the exploration. I deep dove into this. I feel comfortable with the data now. When someone shows me a static visualization and says, this is what, this is the takeaway for it, I question that it is actually true. If I can explore and dive into it myself, I can confirm things. I can sort of set my mind at ease whether the data is valid or if it's them trying to sort of, if they're, we were talking about last time with filtering and aggregation, where an aggregate data could just be hiding the truth behind things, or you're filtering out things and removing the context. Interactivity gives you that context, gives you that ability to reason about the data. But a couple footnotes, of course, is it requires time and attention. It also means stuff is off the screen some of the time, so I can't keep it in working memory. Automatic feature detection versus human-guided search are different things. So if you can have the system automatically pick up key features for you and just send them your way, fine. This is all about the human is guiding the search, or human is guiding the exploration. And an interactive visualization allows you to sort of explore and filter on your own versus letting something else decide how you view the data. It is really, you're trying to find the balance between automation and just saying what the answer is and letting the human find the pattern, because they might find something that you didn't expect. They might want to find it out on their own. It's not great. This is pretty terrible for communicating. It's great for discovery. So if you're trying to, it's great for enjoyment as well. But if you're trying to present a visualization, interactivity, it's only okay. Because the other people watching that are not directly interacting, they're just watching a movie, have to keep up. If I'm in control, I feel like I'm in control. And therefore, I have a better sense of advocacy of how the data is being analyzed. So this is what we're doing. This is the manipulate if you went to the textbook. So we can change what data is being chosen, or change the data view, for example. We can select certain things, and we can navigate. Navigating is technically a kind of filtering, as in I am showing this slice of the data, this part of the data. Selection allows me to change what is highlighted, what's popping out, and changing the data itself might be a completely different perspective of the data, like a different facet. So we can change over time, and we can select. Navigating can be either a zooming in, so the scope of what you're looking at is reduced, the size of the data set is reduced, either geometrically or semantically. We can pan, so that's moving up, down, left, right, that sort of thing. Or we can constrain our data set as in we're only looking at, so navigation, so we can keep all the other data points, but we can just constrain the set that we're looking at. You can also say I'm looking at a subset of the data and then remove everything else, and I'm still navigating through my data set. It's highly related to zoomings. They're not exactly the same. In terms of attributes, that's items. In terms of attributes, we have things like slicing, we have cutting, we have projections. So projections would be like if I have a high dimensional space and I just plop it into two-dimensional space, that is a projection. If I change the projection, I would have a different kind of interactivity. I could cut out certain things that I don't want to see. Or a slice means I am sort of revamping what I'm looking at. We'll look at all those in a second, but the key is that we're changing over time. We worry about how what kind of transitions I have, how I encode the data, and how things are transitioned. So ideally what I want is when I change my view, I have some kind of transition, not sudden jarring blink change and the view changes, but some way of being able to track how things change from one perspective to another. That's an animated transition. It doesn't have to be like and bouncing across the screen. It just has to be allowing you to track what things change. We have selection, which includes highlighting. So I select these items, they become highlighted. They become drawn in a different color, for example, to make them pop. And then I can also pan, translate, rotate, zoom. So Schneiderman's mantra is this. So overview first, zoom and filter, details on demand. Say it again. Overview first, zoom and filter, details on demand. The idea is nobody starts off with exactly the part of the data set that they're looking for. Or most of the time you don't, especially if you're doing discovery. You don't just go like, I know what I'm looking for, it's this. And you certainly don't drop someone in that, even if you could algorithmically find some interesting data point. You don't drop someone into the final solution. What people need to do is get a sense of where they are in the data or on a map, and then you zoom into it. The zoom in filter is remove the stuff I don't care about at a time. And then when I'm drilled into this, when I'm looking at a particular thing, when I really need the details, that's when I show the details. I don't show all the details all at once. I give an overview. I let people filter and select the area of or the set of data or the attributes of the data that I want to look at. And then I can give details when it's needed, but not before. That's the crux of this whole thing. It flies completely in the face of Tufte's work. Tufte's all about this data to ink ratio, and it's all static, and you're not drilling into things. He says different levels of fidelity to look at something, but he never talks about zooming into the data. It's always show all the data, let people make their decision. It's a very different thing because he's a graphical designer. He's not a computer scientist like Schneiderman is. So we want high level at first, then we want to enable data discovery and exploration, and then you don't want to overuse users by providing all the information all at once. So, and here's the actual paper again. So, we also have things like changing over time. I'm going to show you some of these other things, but changing over time, Gantminder is pretty interesting thing. If you've seen, hopefully this will actually work. I haven't tried this link in a while. Hopefully you've seen the Hans Rosling talk on this. The idea is if we hopefully have a play button, there we go. We can actually, this is his TED talk from many years ago. We can details on demand. Notice it does not say China beforehand. It says China afterwards. If I select Russia, it says Russia in 2019. It says India. It might give me some details about, there you go. So there's another detail in there. When I highlight over top of it, notice I have a selection. I have a highlight. I can, I'm getting details. It's the Philippines, for example. I have Russia. I can actually select multiple countries at once to track those particular countries. You do not get this without interactivity. How do you know that people are trying to look at India, China? I accidentally chose India, China, and Russia, two of them being the most populous countries on the planet. I guess they were the large circles. It's hard to miss them. But how do you know that people want to look at those countries? You don't. So the key is you let people interact. You can allow people to choose a particular country or a particular region, choose child mortality, choose income, choose life expectancy. You cannot show all of those all at once. You allow people, that would be, I'm choosing which data set I'm looking at and visualizing that. This has interactivity coming out the wazoo. And then I can monitor this over time from 1805 to the present day and seeing how the world populations actually change over time. But notice I still am highlighting those three countries. And as it goes around, this, by the way, is income versus life expectancy. Notice life expectancy is not good. Oh, and it's keeping it's keeping traces of all of those countries over time. This is Russia with the yellow, that's bouncing. And there's China and India going up, 1870s. And notice China is doing pretty well for itself. This is still India at the bottom. And they're finally catching up with Russia, which was much higher income, much higher life expectancy for a long while, and then they finally catch up. And again, you can look at individual places and what they are. China, right here, where the average age is 77.5 years old in 2019. It was in 1966 or 60, let's say 66, it was 46.5 years old. That's a huge difference. And the income was $1,000, $1,000.30. That's why we do interactivity. It allows things that you would not have expected, or to learn new things. It allows you to drill into new data. So I can look at the United States, turn off all the other ones. So let's see if I can clear. I should be able to just clear it. Maybe I'd need to control click. That's Kazakhstan. I don't want Kazakhstan. All right. Let's see if I have a. Where's the rest? United States. Here we go. I can turn off over here as well. I can deselect all. All right. Then put the U.S. in there, and then press play again. Look at the U.S. population here. You didn't think the U.S. was that small ever, did you? And here's the amount of income they're making. Their still life expectancy is still only around 40 years old. And there we go. That I don't know what that was. Civil War. Where it dropped down. Look at the United States. It's going to drop down in a second, presumably. There you go. World War I. Great Depression. World War II didn't have that many mass deaths. And 70s, it's teetering up a little bit at a time, but it's a fairly upward, stable upward trend with a gradually enlarging population. Okay. So this allows us. Here's I'm gonna have to take a pause for the video in a little bit, but here is the various people that are involved in the Democratic Party, and who are they connected to? What campaigns were they working on? Like the Obama administration, Obama 2012 campaign, the Obama 08 campaign, the Clinton campaign, how all these different campaigns are worked together. And by selecting a particular person, you can see how they're related to all these campaigns. If I select the Clinton 08, I can see who was in Clinton 08 that then moved over to Obama 12. I can't do this if I don't have interactivity. I can't show it all at once. I need to do it. I need to drill into the data. So unless I made an infinite number of these different ways of viewing the data, like all these snippets one after the other, I wouldn't be able to get this. This would be selection. So I'm gonna stop at selection in a second. Hopefully it'll work properly. Or maybe it won't even let me do that. I'm just gonna cancel for now. And PowerPoint's up. I'm going to take a pause of this because I think, no. Wow. Okay. And then here's your classic navigation, where I can drill in by zooming in. That's a geometric zoom in this case, into this data. There's also technically a semantic zoom. The amount of detail I get as I zoom in also changes. The amount, so a semantic zoom is I zoom in based off of a particular idea, not necessarily based on geometry. We'll see a semantic zoom in a second. I can translate, pan and translate. I can drag this thing around, and I can look at a subset of the data at any given time and look at that. So semantic zooming here would be an example. This is from my friend Dan Archambault. The idea is if I have a click, or click, depending on how you want to pronounce it, and I want to see what's in there. If I drill into this thing, I will get stuff related to this, but it's actually not, this is actually not geometrically positioned. I want to have more detail on this part of the graph, but the graph doesn't actually exist in space. So I'm showing things that are related to the stuff over here based on concept. Or maybe I could semantically zoom by only showing things that are only nodes that are involving, if this was like internet hubs and connections, maybe I only want to show ISPs in commercial domains, and everything else sort of zooms in. It's relative to those particular items, and I relay out everything. A semantic zoom is I zoom in and show less of the total, but based on a concept or based off of the data, not based off of geometry or where it is actually in physical space. So I'm going to take a brief pause because I got to go pick up my kids actually. And then when we come back, we're going to be looking at attribute reduction right here, like slicing, like cutting, and like projections. All right, talk to you soon.